Sit-im. Sit-im is the opposite of stand-im. Opposite of running around. Sitting. Sitting is the opposite of standing. Sitting is the opposite of running around. Howdy, howdy. Hope everybody's having a good beginning to their Tuesday. How tall am I? I am 6'7". Yeah, sorry, I had to. How can I learn physics online? Well, what you can do is you can find some good resources. So there are some places like MIT OpenCourseWare, there's Khan Academy. These are like standard good resources. The other thing is that there are some free online textbooks. The one that I'm most familiar with, which is a good place to start, is Rice University. If you go to openstacks.com, I think it's called OpenStacks. You go to openstacks.org. There's a book called University Physics Volume 1. It's an excellent book. Like I've taught out of it. I've used that textbook as a teaching tool when I was a grad student. It's very, very good, and I would recommend it. What's my favorite color? Something like green. How do magnets pull things without using energy? Well, look, the presence of magnets means that there is potential energy. Magnetic potential energy in particular. So that magnetic potential energy is just converted into kinetic energy. That's all. Are you smarter than Ed Witten? Oh, probably not. I need help understanding how a black hole tilts all future paths inward. Like, what does that mean and how can it do it? Look, so the whole business behind gravity is that it curves space-time entirely, rather than just curving space or just curving time. And what that means is it can mix space and time. Regular gravity causes time to bend towards space, if you will, the time-like direction. And so it's perhaps not so surprising that a black hole will do the same to the extreme. Could you please explain neutrinos? I know a little bit, but I still didn't understand well. So neutrinos are very closely related to electrons. They can turn into electrons via the weak nuclear force. But put bluntly, a neutrino is just an electron without an electric charge. They also have different masses. They're much lighter. But other than that, they behave in basically the same way. Thoughts on quantum computing? It perhaps might be useful for solving certain problems. I don't think that anytime soon it'll be a force in the household, because household problems, you know, we don't need quantum computing to play Crisis, right? I really understand how observation changes the state for quantum stuff. I feel like it almost gives human observation some weird mystical. No, there's nothing mystical about it. The mainstream view is merely that it's not observation, it is interaction. If you have a big thing, and like a big macroscopic thing like a dial or like a voltmeter or something like this, and you use that to interact with the quantum system, that quantum system will kind of spread its quantumness out to the macroscopic system. But the macroscopic system is macroscopic, so that'll just average out. And so the quantum system will behave differently as a result of that interaction. It'll kind of lose some of its coherence, if you will, because of that interaction. Question, do you recall the theory about folding space to travel faster through space? Yeah, that's like a standard sci-fi trope. There is an idea that is kind of based on that, like an actual physics idea called the warp drive, which was created, or which was theorized by is his name Jose? I think he's a Mexican physicist, but I think his name is Jose Alcubierre. Anyway, the trouble is doing so requires matter to exist that we have good reason to think doesn't exist. So probably not real. Probably not a real thing that we can do. Why can't an extremely strong person pick themselves up by their hair? So if they were to pick themselves up, that means that there'd be a force, their arm would apply a force to their hair. Their hair, being connected to their head, would apply an equal force to the rest of their head. Their head, being connected to their body, would apply an equal force to their body. And their arm, being applied to their body, or their arm being connected to their body, would have the body provide an equal force to the body. So you pull the hair up, and it pulls the arm down. Miguel, it's Miguel Alcubierre. Sorry. That's my bad. Kerbal Physics, welcome. What's the difference between Newtonian and Einstein physics? So Newtonian physics is, it's the physics of billiard balls, right? Things bump into each other and then they bounce around and there's forces and accelerations and everything. And other than that, everything is hunky-dory. Gravity is just a thing where you have two things and they just attract each other. General relativity takes that and says, well, what if gravity wasn't that? And what if there is a universal speed of light? Universal speed limit, namely the speed of light. Well, then you get a whole bunch of weird stuff. For example, you get that gravity distorts time and it distorts space. You get that depending on how fast you're moving, you will see different things relative to some other person. There's a bunch of extra details that get added in just from this simple observation or this simple proposal that the speed of light is constant for everybody, and that matter warps spacetime. How do you measure g-forces? You can use an accelerometer. From Jack Fetter with the $2, my cat is staring at the lamp. He knows. Well, tell your cat, welcome to the Illuminati. I'm about to get my bachelor's degree and I don't want to go to grad school. Any job advice? Apply for, I hope you took some like programming classes, or I hope you took some economics classes. In a big crunch model, would it not be possible that while there may be an infinitely sequential number of crunches, the end state and subsequent initial state be different each time? This is something that, so I don't know if it's possible. I'm actively working on trying to construct a model to see if this is a thing that can happen using kind of like standard known physics. But with the presupposition that, so, the way that you go about building a model is you kind of have like a goal that you want your model to do or that you want your model to express. And it is harder than you might think to make it so that you get different results each time. And so maybe it's not possible. This is something that I'm like actively exploring. Can you tell us why simulating the universe is impossible from the incompleteness theorem perspective? I don't think that the incompleteness theorem perspective really speaks on simulating the universe. Is it correct that it's possible to create antimatter in a fusion reactor, although expensive? In a fusion reactor? No, not really. I guess that you could create antineutrinos, but that's about it. No, we can create antimatter in other cases. We can create antimatter in particle accelerators, for example, but not in fusion reactors. Gravity is the curvature of spacetime. Can future spacetime curvature affect the present? Kind of, sort of. But not like far in the future. It's infinitesimally in the future. So the way that you calculate the curvature of spacetime is, it's like calculus, right? Curvature is essentially two derivatives of it's called the spacetime metric, combined in the appropriate ways. And so in particular, you have to take derivatives in the time direction. So you have to take the difference between, and remember what a derivative is, it's an infinitesimal difference between 2 points. So part of curvature tells you about what's going on in the future, or rather it encodes information about the future. Is it possible that some parts of the universe function by physics that is not recognizable to us at the moment? I mean, it's possible, but like when we go out and look at the universe, all of the physics of like, distant galaxy number 3012 looks the same as the physics here. Can you explain what a singularity is? Yeah, a singularity, at least in the mathematical sense, a singularity is okay, there's a lot of different kinds of singularities that I should be careful about. In physics, what we mean by singularity is that you have some equation, some model, some like law of physics or something that makes a prediction. Think of like classical electromagnetism from the late 1800s. If you have a charged particle, like a point particle, the closer you get to the particle, the stronger the electric field gets. And once you're on top of the particle, the electric field is infinitely strong. That would be a singularity. And typically, when these show up in our physical theories, it just means that our model breaks down somewhere before you get to the singularity. So what we found out in the 30s, 40s, and 50s is that actually these point particles, these point charges like electrons, are not, they're not really just like a zero-dimensional thing. They are like a quantum wave. And as you get closer and closer, there are electric fields that you kind of screen away, electric and magnetic fields that you kind of screen away as you get closer and closer. And so you don't end up with infinite electric field as you get closer. It actually gets like the amount changes because you're kind of screening away some virtual particles is the way that it's usually explained. But the point is that we have a new explanation for why the old theory breaks down and our new theory doesn't have that singularity. So this is a signal that the theory is probably incorrect at some scale. Could you explain the block universe? Does the future already exist? So I do have a video on this. I'm planning on recreating it just because it's an old video. The idea is merely that in general relativity, the future is no more special than the past. And in general relativity, like we have reason to think that all moments of time are equally part of spacetime. And that spacetime is just a unit as a whole. It's not a thing that you should slice up. I mean, you can slice it up if you want, but like there's no ontological preference to any particular slicing of the spacetime, and that slicing gives you things like past, present, and future. And so under this view, it's just that you should think of the whole of spacetime as existing, and we're just moving around through it. What would happen if the sun was replaced with a black hole of the same volume? Oh, a black hole of the same volume, we would probably be in for a really bad time. I mean, a black hole the size of the sun, or a black hole the mass of the sun, would be like 3 kilometers across. A black hole with the same volume of the sun would probably weigh like, you know, have the mass of like, I can't even estimate it. What the sun is 13 times the size of. No, the sun is 100 Earths across. The sun is, I think, 100 Earths across. And Earth is like 6,000 miles across, or 8,000 miles across. So 4,000. We're talking like 4 million miles, 8 million miles across, I think. So we're talking about scaling the volume up by like a factor of like 2 million. And then we want to take the cube root and square it to give us the increase in factor of mass. So what's the cube root of 2 million? I don't know. My calculator can't do the cube root of 2 million. Well, we can estimate it. So the cube root of 1 million is 100, right? So it would be like the cube root of 2 times 100, and then we would want to square it. So it's 2 to the 2/3, sorry, it's 2 to the 2/3 power times 10,000. So the black hole would be on the order of, you know, 10,000 times bigger, 10,000 times more massive than the sun, which would be really bad. And we would just fall in. We would die. Thanks for the question, though. That was fun. I think my estimate may be wrong about the diameter of the sun, so I'd have to go back and double check that. But I was going strictly off the top of my head. What does the Born-Guth-Vilenkin theorem really say? Well, it's not a theorem. At least as originally posed, it's not a theorem. It's false. It's like strictly false. It has counterexamples, which means that the theorem has a hole, or the proof of the theorem has a hole. But the idea of the behind the Borguth-Blanken theorem is merely that if you have a universe that on average is always expanding, then it must be smaller in the past and smaller in the past, and so you end up at a singularity. That's the idea. Technically, you end up at a geodesic, a place, you end up where your spacetime ends up with almost all of your geodesics being incomplete. But again, it's not a theorem. It has counterexamples, which means it's strictly false. Beginning and end don't make sense in the B theory of time, though. I mean, like, you can talk about events in spacetime that mark the beginnings of things or the ends of things or something like this. There's no issue there. 237,000 solar masses. Okay, so I was off by about an order of magnitude. I'll take it. Howdy, Mr. Earth Guy. Hope things are going well. Imagine hitting a dust particle traveling at the speed of light. Well, dust particles can't go the speed of light. They can go really fast, but they can't go the speed of light. Why is there matter-antimatter imbalance? That is, strictly speaking, one of the open questions that nobody knows the answer to. What's your opinion on quantum orbitality? That it's not really a thing. Why is it that one thing is 0 Kelvin, everything else must be... Why is that one thing... I don't know what that question means. Could dark energy be explained by the Casimir effect? In a sense, that's the idea behind dark energy being vacuum energy. It's sort of related to the Casimir energy. However, that would imply that dark energy is constant, which we have increasing evidence it's not. Does a single photon pass through... Does a single photon... What does this say? Does a single photon passes through both slits? If no, then can you please explain the Elitzer-Weidmann bomb testing experiment? Yeah, so it just depends on what's going on. Like, I have a video on the Elitzer-Weidmann bomb testing experiment, but yes, generally, a single photon is not like a billiard ball. It's not like a little bullet that can only pass through one thing. It is a wave, and waves pass through both slits. I read a science article the other day that they managed to measure the speed of quantum entanglement. Quantum entanglement? This is probably how long it... Okay, so I see it here. Quantum entanglement speed is measured for the first time as too fast. Okay, let's just skim this. Because I'm a little bit skeptical that this is written the way that the headline is actually correct. Yeah, okay. So this is perhaps unsurprising. So this is talking about how quickly can two particles go from, or can one particle entangle with another particle. But this is just the interaction time. And so, of course, it's not going to take place instantly. That's not particularly surprising. What this isn't measuring is how fast affecting one entangled particle affects the other entangled particle. It doesn't seem like that's what they're measuring. Yeah, so there's nothing so surprising here. Why can't 0 Kelvin be reached? That is the third law of thermodynamics. And basically, the reason why this works is you can just like, you can basically prove this using standard thermodynamics, that the amount of temperature decrease that you get for any like finite work that you do, or any finite heat extraction that you do, the amount of temperature change that you get is always going to be some fraction of the difference between the temperatures, the initial starting temperature of the thing, and 0 Kelvin. And so you can always like reduce the temperature by like half, by half, by half, by half, or something like this. But you will never actually reach 0 in a finite number of steps. From Nectu, with the $5, can you explain the process of how new scientific discoveries go from the point of discovery to the college classroom? No, I'm not old enough to actually have seen that happen. So I don't know. I would imagine that generally what would end up happening is that you have something that becomes so mainstream in the scientific view. So you have like some discovery becomes very, very mainstream because it's repeated over and over again. Maybe somebody wins a Nobel Prize for it, whatever it might be. And then people start writing books about this topic. Like this is generally what happens in fields anyway. You have people that write books about like new things. There are so many books that people write. Most of them are not ever used in universities. But then I would imagine that you end up with, you have a professor here or a professor there. They take some of these books, and most of them will be bad, but some of them will be quite good descriptions of this new thing. And then they will incorporate a chapter or 2 chapters into some advanced grad level seminar or something like this. And I imagine it just kind of percolates down from there. From Lise with the 5 Canuck bucks, Spacetime, fundamental or emergent? Is this an opinion question? Because nobody knows the answer to this yet, right? Nobody knows. Like, this is an open question. I don't really have an opinion on it either. I kind of go both ways. And no, I'm not going to play the theme song. I don't know where the theme song file is. I just have the 19-second clip at the end of the videos. You've described yourself as between moral quietism and moral anti-realist. I don't know what either of those mean. Can you explain it? So moral anti-realism is just like, you can think of it as like subjectivity, that like there isn't some objective fact about morals or about ethics that exists in the universe, that these are like constructed by humans, for example. Moral quietism is merely the idea that when people are talking about, when people are having like ethical debates or moral debates, they're really having like a difference of language, and they're just kind of confused about the whole thing. Like they're using language in inappropriate ways to try to describe the things that they're talking about. That's at least my understanding. I'm by no means a moral philosopher. Can we decelerate a particle from faster than the speed of light if it was already to less than the speed of light? No. No, you cannot. In fact, there was an interesting paper on this where it was discussing the kinematics of faster than light particles. And like in principle, you can work out the kinematics of faster than light particles, but it takes energy to slow them down. They have an opposite relation with kinetic energy. Can you explain the Hamiltonian renormalization of a quantum field theory? Not on a live stream, no. Also, now that I think about it, the renormalization that I'm typically familiar with is renormalization via like the path integral. I'm not familiar with Hamiltonian renormalization. I take it by Hamiltonian renormalization, you mean like a method? Or do you mean like by adjusting, or do you mean like renormalizing the Hamiltonian so that it becomes like, renormalized, regular, non-infinite? If by that, then you should probably think instead about renormalizing the Lagrangian, which is related to the Hamiltonian, at least that's the idea. Did Richard Feynman play the bongos? From what I've heard, yes. Thank you for answering about the Elitzer-Weidmann experiment. If a single photon behaves like a wave, then when do we join probability in 2 arms of an interferometer? Why we assume it to be less than 1? I do not understand that question. Do you believe immortality would be possible? And if it was possible, what's the hardest part of it? That doesn't sound like a physics question. In light of GR, are there any conceivable paths to anti-gravity technology? Yeah, I mean, you need matter with negative mass. And so no. I mean, that's what you would need. There's no known path to that because it's possible that those things don't even exist. Why does the arrow of time flow forward in a block universe? In a block universe, there is no intrinsic arrow of time. That's the point. There is an emergent arrow of time in a block universe. That emergent arrow of time typically is associated with like thermodynamics. Are atoms 99.99% empty space? No. Unless by empty space you mean like there's not a bunch of particles touching each other. But no. So atoms are filled with electron wave functions. Do you have any pets? Yes, I have a cat. A particle moving at 1/2 light speed is observed from a planet going the opposite direction at 2/3 the speed of light. From the point of view, does the dust look superluminal? No. Velocity addition is not trivial in special relativity. In special relativity, velocities add in a non-trivial, non-linear way. Now, at low speeds, like speeds close to 0, velocities do just approximately add exactly like you expect them to. But at speeds close to the speed of light, like half the speed of light, 2/3 the speed of light, velocity addition is no longer trivial. From Hadrian Olive, with the $2 or with the 249 euros, the most interesting scale, very big or very small. I like very big, but probably very small is the correct answer from most physicists' perspective. What textbooks would you recommend for studying classical mechanics, like 8.01 on MIT OpenCourseWare? I'm not familiar with 8.01 on MIT OpenCourseWare. You can just look, though. Do they not recommend textbooks? I'm surprised that they wouldn't recommend textbooks. The textbook I've taught out of is, and it's open access, it's openstacks.org. It's supported by Rice University, and it has a physics textbook called University Physics Volume 1, which I think is quite good for intro physics stuff. How does the phenomenon of quantum superposition allow a particle to exist in multiple states simultaneously until the moment it is observed? I don't know what you mean by the word how. So the way that we describe quantum anything is with waves. And waves can stack in the same way that you can play multiple strings on a guitar simultaneously. The sound waves that are produced will stack. And so it's not just like a high C and like a D, like a D4 or something like that. Separately, the sound wave is in a superposition of both. It is both the high C and the D4, right? And quantum particles are much the same way. It is not, you can have a quantum superposition, which is just the stacking of waves of a particle in this state and a particle in that state. From Jack Fetter with the $5, can you explain why my mom will ask me a question, then ignore any answer I provide, and explain what she then plans to do for 15 more minutes? Oh no, I can't. That is an unsolvable problem. From Simeon Urchin with the $5, so are virtual particles real, or more like quasi-particles a good math tool? By the way, quasi-particles are coolest, #TeamPhonon. In some sense, quasi-particles are more real than virtual particles. Virtual particles like are not detectable particle states, right? Quasi-particles are detectable particle states, right? Like quasi-particle, they just aren't fundamental particle states, but they are detectable quantum states. They have like, they lie in a mass shell and all of this lovely stuff. Virtual particles are not even in principle detectable. And the reason, and you know, the way that you should think about them is merely a math tool, not something that you can detect. They're merely a way of decomposing a non-particle field configuration into particle-like states so that particle physicists can do calculations. There's a famous clip of quantum physics professor who tells his students that he doesn't understand how it works, and by the end of the lecture they also won't be understanding it. Do you agree? I mean, it's cheeky and it's funny, but no, I think that it's understandable. Why can't information travel faster than light via quantum tunneling? Well, so there is a phenomenon called, or there's a theorem, this is a theorem, not a theory, there's a theorem called the no communication theorem. And basically what it elaborates on is why it's not possible for you to transmit information via, oh, you said via quantum tunneling. Quantum tunneling is not instant, that's why. But if you meant quantum entanglement, then yeah, the no communication theorem basically elucidates on why. And the explanation is basically there's nothing that you can do to the particle here that the other person will be able to detect without themselves measuring it. And they won't know that their measurements are the result of what you did until they go back and compare with you. I should hydrate. Are there any speculations on the features of dark matter, what particles may be made of? Yeah, there are tons of speculations, just none of them have been confirmed yet. Define observation in quantum terms. There's not really like a hard and fast definition, but typically what's meant is some sort of interaction with a macroscopic system. So you have a microscopic quantum system that interacts with a macroscopic non-quantum system. We would generally call that an observation. But there are other kind of more subtle notions. I can't figure out how a B theory of time could be infinitely growing. My brain won't do it. In the B theory of time, you don't have something that's growing. You've zoomed out of time. There's no change. Once you've left spacetime and you've zoomed out, it's like a loaf of bread. The loaf of bread isn't changing, even though each slice of the bread might be associated with a moment of time. All of the moments are there. The loaf of bread is just sitting there. From Holy Gore with the $2. Is that in bad faith? Not bad faith, sorry. It's not bad faith. Is that... I know that the... Like, this is like a racist thing, isn't it? Or at least I know it started out that way. I think. Like, I don't think that, like, you probably didn't know, but I think that it started out that way, right? Derogatory, yeah, something like that. Disavow, Holy Gore. No, just don't, just like, you know, now you know. Is energy necessary, or is it contingent on the universe existing? Is the universe described as only energy? Energy is not a substance. It's not like a thing that exists. It's like a property of things that exist. So it would be like saying, is temperature contingent on the universe existing, or is the universe described only as temperature? Like, it's not really, it's kind of a category error. Temperature is like a property of things that exist. How did Fleming get his left-hand theory? I have no idea what you're talking about. The joint probability detection is less than 1 if we pass a single photon through a Mach-Zehnder interferometer. Why is it so if the single photon behaves as a wave? The joint I'd have to go look at the calculation. So you're saying the joint probability of so a Mach-Zehnder interferometer, for those who don't know, is like an interferometer that looks like this. You have a beam splitter, and then you have bounces, and you have a beam combiner. But I'm pretty sure that if you sum up the probabilities of detecting the photon at either of the two final detectors, you get 1. I'm a little bit skeptical of this claim, but I'd have to go back and look back. I could be wrong. I'd have to think about it some more. How does the ADS-CFT correspondence resolve the information paradox if bulk locality is only an approximate property of the boundary's entanglement structure? I'm not sure it does. I mean, it could. I haven't looked into the information paradox a whole lot. It's not something that's all that interesting to me. So like, I'm not actually familiar with the proposals for ADS-CFT resolving the information paradox. I'd have to look into it more. Do we detect the Higgs field? Yeah, we detect the Higgs field by detecting particles, particle excitations of the Higgs field. So you dump energy into something, and then out pops something that behaves like a particle excitation of the Higgs field, the Higgs boson. So that's how we indirectly detect the Higgs field. From Tim for Pele with the $10. I'm not sure I can trust you anymore, since that French flurf outed you as a dummy who clearly has no real physics knowledge. But what's the difference between non-abelian and non-commutative? They basically mean the same thing. I guess that non-commutative is probably used more in physics, and non-abelian is probably used more in mathematics. Or perhaps a better way of phrasing this, perhaps a more satisfying answer, is that non-commutative is kind of used more generally just to refer to the order of matters, whereas non-abelian is typically used to refer to groups and algebras, like specifically. From Demtro with the $10, I'm trying to grasp special relativity in that as you get closer to the speed of light, time slows down for you relative to others. Can you explain or suggest resources to help me understand better? Well, look, so it really depends on which part you're struggling with. But like, this is just what the math says. Now, if you're asking, like, what does it mean? Like, what's the intuition there? The intuition that can be kind of helpful, although it's not 100% correct. But there is some intuition that has been satisfying for other people, namely that if you imagine everything travels through space-time at the speed of light, at a fixed speed, but when you're not moving, all of that speed is through time, and when you are moving, all of that speed is through space. Or when you are moving, some of that speed is through space, then you can understand that traveling more through space means you're traveling less through time. That's a piece of intuition that some people have found useful. It's not quite right, but it at least grasps at something correct. Dr. Blitz, I remember you said you were writing a paper on presenting a case against why we're not in a black hole. Can you explain how one can try to work with that? Yeah, so I mean, it's still very much in like the brainstorming idea. I think I actually have like a mechanism to show that it can't work, but it's really just reliant on this idea that if we were in a black hole, well, rather it's a refutation. The idea of the paper is something like this. There's this idea that if we were in a rotating black hole, then it would be the case that we would see a bias against, like a rotational bias in galaxies. This is why this made the news last year, because some guy was like, oh, we found a bias in the rotation of galaxies and most black holes are rotating, therefore we should be in a black hole. But it turns out that if you work out like the interior geometry of a rotating black hole, while stuff on the outside will be forced to rotate with the black hole, stuff on the inside doesn't do that. The interior of the black hole just doesn't behave as you might expect, and so you'd actually, at least in standard general relativity. In other theories of gravity, then you absolutely can get that, but it's just not the case in standard general relativity that you would expect rotating galaxies, you would expect a rotational bias to galaxies if you were inside a rotating black hole. Just because the dynamics of the interior are just static, like you wouldn't notice anything different. You wouldn't notice anything about the rotation. But yeah, I have some more technical details, but I just haven't sat down and actually started trying to formalize it. What do you think about Lise Mollins calling special relativity a useful fiction? I've never heard him say that. I'm not sure if it's correct to call it a fiction. If a photon is traveling at the speed of time, is it actually moving at all? Well, it's traveling at the speed of light. The speed of time doesn't really have... The speed of time isn't a thing. Time isn't a thing that's moving. But yeah, photons are moving. Can you explain the difference between a flat universe and a curved universe? Yeah, so we're talking about topology here, or rather we're talking about intrinsic curvature. So the idea is, imagine that you take away all of the matter in the universe, all of the energy in the universe, you just take it away. What's left? Well, it's possible that you could just have flat, empty space. But it's also possible and totally consistent to have a universe that is just, has like a kind of symmetrical curvature. So like think about how a sheet of paper is not curved, but the surface of the Earth is curved. The surface of the Earth is a two-dimensional sphere. A sheet of paper is, some, it's homeomorphic to a disk, but it's neither here nor there. The point is that the universe, even in the absence of everything, could have curvature, and that curvature tells us something, or could tell us something about topology. Namely, if our universe is positively curved, like the surface of a sphere, then our universe would wrap around on itself. If our universe is negatively curved, then it could wrap around itself, but in non-trivial ways. You could have things that are, you could have, say, handle bodies that describe the topology of our universe. If our universe is spatially flat, then you can also have the universe wrapping around on itself, or you could have it be infinite. So there's just a whole bunch of different ways that you can, a whole bunch of different consequences of the various curvatures of the universe with regards to like the shape of the universe. Which is why it's an important question, by the way. From Mr. Pancake with the $5, if you had to make a guess as to what causes gravity, what do you say? Do you think we will discover a graviton one day? I think that this is an ill-formed question. And look, I'm not saying, like, this isn't your fault, Mr. Pancake. A lot of people ask this question with the expectation that there's, like, some cause, some ultimate cause of things. But, like, we don't... You could ask that exact same question about electromagnetism, and we don't know the answer. We have that electromagnetism is, like, the way that we describe electromagnetism, even at the most fundamental level, the quantum level, is that it is a curvature in a U1 principal gauge bundle. That's what the electromagnetic field is. And that principal gauge bundle interacts with non-trivial representations of fields, or interacts with fields that have non-trivial representations in the U1 that are non-trivially, what do I want to say? It interacts with fields that occupy non-trivial representations of that gauge group. And like that's the okay, so what causes electromagnetism to interact with non-trivial representation? Like that's just what the laws of physics are. Regardless of the fact of whether or not we have a fundamental theory of gravity yet, maybe we do, maybe we don't. It's just like the question of causes, what causes gravity, that's probably just like the way the universe is. Which I know is unsatisfying, but like this is like laws of physics are not the kinds of things that typically need causes. From Entomo Blonde with the $10, if I theoretically had a piezo composite that would not outright fail in extremely low Arctic temperatures and it'd conform to a robot chassis, could it improve upon the robot's performance? Why would a piezo composite help you here? I imagine by a piezo composite, you mean like something that is piezoelectric? I don't understand why those two things would be related. Performance in what way? Why is it in the Arctic? How is the piezo composite helping? I don't understand that question at all. It's okay. It's okay in Tumble Blonde. Sorry, I just want to double check something. Okay, so from Chase, thank you, Chase, for answering this question. This is helpful. So thank you, Chase, for the $20. The black hole information paradox is resolved in ADS quantum gravity. What remains open is how this manifests in asymptotically flat spacetime in a realistic 4D gravity without a known holographic dual. But within ADS CFT, the black hole information paradox is no longer considered open. Okay, no, that's a good point. So I guess if you take the full ADS CFT correspondence, where you have full string theory in the interior, then string theory resolves this, right? By having like, what is it, like a fuzzball? I mean, I guess there's a whole bunch of different ways, at least one way that you can resolve the information paradox in string theory, right? Once you grant string theory, then there's no issue, right? I could be wrong. We have Chase is a string theorist here. So look in the comments. I'll highlight the comment that Chase sends with an explanation. From Just a Voyager with the €2, thoughts on universality. Do you mean your universality in like the physics sense? Because there, it's quite an interesting phenomenon. It's fascinating that you can describe so many different physical systems with like essentially the same laws of physics. That's really, really neat. I just don't do condensed matter, so universality is not so relevant to what I do. Can you prove you have a PhD? Yeah, I've done it on stream multiple times, but it's annoying to like self-censor it, so I'm not going to do it right now. What do you think? Oh, from Dwayne Warren with the $20. Thank you so much. Why does the second law of thermodynamics emerge so cleanly and universally from time-reversible microscopic laws? And what, if anything, does that tell us about whether the arrow of time is fundamental or emergent? So this is a good question, by the way. This is like an excellent question. And I do have a video on this. But the idea is merely that a second law of thermodynamics only emerges when you have a low entropy, when you have a low entropy configuration. If you started out with a thermodynamic configuration that was in equilibrium, there would be no second law of thermodynamics. The entropy wouldn't change, and you would have no you'd have no arrow of time that emerges as a consequence. The idea is merely that from a low entropy initial state, if you wind the clock back, it is overwhelmingly likely that the entropy will increase. And if you wind the clock forward, it is overwhelmingly likely that the entropy will increase. If you wind the clock in either direction. Now, if you're asking why then does it pick, why then do we experience the future, or why then do we experience a arrow of time? I mean, arguably it's because the very early Big Bang, or inflationary state or whatever was extremely low entropy. And so the entropy has been increasing, say, in both directions. This is an idea that is talked about by Carol and Chen. The entropy is increasing in both directions, and time runs forward in both directions. Insofar as like organisms in both directions of spacetime would have memories of times closer to the Big Bang. That's the idea anyway. Just looking to make sure that Chase didn't answer. Okay. What is the single electron theory, and does it prove there's no God? The single electron theory is an idea that was popular or it wasn't even that popular. It was an idea proposed by John Wheeler, I want to say, in like the 50s. is like, hey, why is it that all of the electrons look the same as all of the other electrons? And why do the positrons, which are antimatter electrons, why do they look like they're backwards time-traveling electrons? And the answer that he gave is, what if there's just one electron? But then we did quantum field theory, and quantum field theory better explains why all of the electrons are the same. So like the single electron theory is just not like a thing. It's like 70 years old. Nobody's really thinking about it seriously. Where did you think gravity came from? Gravity is a law of physics. It's not like a thing that has to come from something. Yeah, single electron hypothesis in the Big 26, right? One sec. When will you start covering consciousness? I won't, because it's not my field and it's also not particularly interesting to me. Do you believe in the graviton? In some sense, I mean, in some sense we know that the graviton exists, but it's probably not like it's probably not like the final theory. It's probably not like the final description of quantum gravity. It's just perturbative description. How big is the non-observable universe? Well, I've seen estimates that it's like at least 300 times bigger than the observable universe if it has a finite size at all. From Grimfellow with the $5, do the double slit thing. You know you want to. What double slit thing? What thing am I supposed to do? The double slit experiment is like not particularly deep. It maybe was considered deep like 70 years ago, maybe even 80 years ago, but like we have a pretty good understanding of what happens there. There's like several different complementary ways of understanding and interpreting the data. How do you become a king in linear algebra and probability theory? Study hard, I guess. I know it's not satisfactory, but like, that's how you get good at things. You practice over and over again. Is all of spacetime curved even if very slight? Can flat spacetime even exist in a universe where anything exists? Yeah, in some sense, yeah. The answer is yes. To your first question, and then the answer is no to your second question. Is it expected we would find new physics beyond the observable universe? No, it's sort of expected that we would see the same physics. I've heard Ian say that the universe is a mathematical object. Do you know what he means by this, and do you agree with him? I don't agree with him, but he's taking an extreme Platonist view that, or an extreme mathematical Platonist view, that all that exists are mathematical objects because mathematical objects perfectly account for all of the properties of the things that exist, and so those things are best described by merely the properties that they have, which are mathematical in origin. That's the idea. I don't take that view. I'm an anti-Platonist. How did they discover gluons? I actually don't know the history there, but it was particle accelerators. Shouldn't there be different variations of the Earth given it wasn't created by any entity? You mean like other planets? There are other planets. My uncle is a physicist professor at our state university. He absolutely believes in God. Okay. There are physicists that believe in God. They're just they just occur less frequently than the general population. Is water really harder than concrete when you are falling at terminal velocity? No, I don't think so. Water doesn't change depending on how fast you're falling. It's just the impact force changes depending on how fast you're falling, and the impact force can be comparable to that of concrete depending on how fast you're falling. You think you can get through engineering undergrad without ever using the textbooks? No, I doubt it. By the way, now's a good time to shill. So if you guys are 18 plus and you want announcements of where I'm live, especially if I'm visiting somebody else's live stream, or if I am posting a video, or whatever, or if you just want to ask me questions, the best place to do that is to join the Discord server, if you're 18 plus, of course. All you have to do to join the Discord server is type in discord.gg/drblitz, Dr. Blitz, into your browser or whatever, and you can join the Discord server. It's a lot of fun. We have a great admin who's running the server. Her name is Lilith, and yeah, look forward to the server being greatly improved, even more so than it is now. We'll be adding bingo at some point in the near future for debates, which is always fun. Second thing, if you want access to emojis on YouTube, in YouTube chat, there's a whole bunch of emojis that you can get access to, like 7 or so on each channel. They're the same. And we're going to be adding more, which are great for reactions for during debates, or, you know, just spamming, not spamming, but using fun stuff. Access to those emojis and access to my debate notes that I use in my debates. These are accessible for like $4 or $5 a month by becoming a YouTube member. And you'll have access to all of my notes and all of the emojis. You can also consider becoming a member on Patreon. That also gets you access to the debate notes, but not access to the emojis, because I can't link it to YouTube because it's annoying. So consider that. There's also a super high tier on Patreon if anybody wants to subscribe to that. Basically, we'll get you acknowledgements in all of my academic papers, and you'll get quarterly updates from me like I work for you. So that's a fun idea. Anyway, let's read some super chats and we'll continue answering questions. From Garain with the $5, have intermediate mass black holes been found in globular clusters and dwarf galaxies? I don't know. I know that we've seen intermediate mass black holes in like black hole collisions, but I don't know if we've actually detected any outside of collisions themselves. That's probably a Googleable answer though, or Googleable question. Have you ever thought of being a Wall Street quant? I mean, I've thought about it insofar as I thought about how I don't want to do that. Will the size and mass of the observable universe, or with the size and mass of the observable universe, is it possible we're not in a black hole? Yes. Yeah, of course it's possible. How could engineers in general, or chemical engineering students in particular, get into the frontier of physics science? Well, change your major to physics. Why is science so absent from politics? The obvious dismissed. I don't know what that question means, but it shouldn't be absent from politics. It's just our current administration is basically trying to send us back to the Stone Age as far as science is concerned, or, you know, make us a third-tier country as far as science is concerned. Sorry. Got a text message about Okay, that's fine. Is non-unitary evolution during black hole evaporation a fundamental law or a breakdown of holographic complementarity? You'll have to talk to people who do like that kind of thing. That's not the kind of physics I do. But importantly, it's not clear that that black hole evaporation is non-unitary, right? That's just not clear at all. Like in principle, unitarity is supposed to be like absolute. So if you're breaking unitarity, then you have some sickness in your quantum field theory, or in your quantum theory at all. It doesn't even have to be a field theory. From Vader Sawyer with the $5. Hi, Dr. Blitz. Has there been any work on low L CMB anomalies coming from a reduced dimension early universe? Curious if that's been looked into. I know that I was actually reading something about this, about something like this recently. They weren't talking about low coming from reduced dimensions, but people do look for explanations on the low L CMB anomalies, definitely. I haven't looked at specifically that. Although I don't think that you would want, I don't think that dimension reduction would get you low L CMB anomalies. You might want like some periodicity, might get you low L CMB anomalies, but I can't see how dimension reduction would get you that. From Grim Fellow with the $5, why are chemistry majors more attractive than physicists? Bet. Not true. Definitely not true. False. It's exactly what a chemist would say. Is curvature tension a likely avenue to lead to a theory of... I don't know what you mean by curvature tension. Are you in whole hog on string theory, or are you reserving judgment until we have observable evidence? Yeah, I'm not a string theorist. I don't even think that string theory is like, you know, true necessarily. I think it's definitely worth... I don't think that it's like a waste of time though. Why exactly do black holes evaporate? Well, semi-classically, black holes evaporate basically because of quantum tunneling from the inside to the outside. That's the simplest explanation. If Ton 618 supermassive black hole was 5 light years away, would we be dead? I think I actually made a video on exactly that question. So you should go watch it. It's from like a few months ago, I think. If I remember correctly, the answer was yes. I've heard it claimed that the matter energy with within the observable universe radius is already within the Schwarzschild radius. Is that true? Yeah, it is, but that doesn't mean that the universe is a black hole. Like, it's not sufficient just to have enough energy or enough matter or mass in a volume in order for it to be a black hole. That's just not the case. For example, you could have a universe that is very, 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 very dense, and is dense throughout the whole universe in a uniform way, and there's no black holes present. We need to invent new mathematical system not based on decimals. That wouldn't really do much for us. So is there a boundary line that you cross when you cross the event horizon, or a black hole? I mean, yeah, it's called the event horizon, but the actual existence of event horizons depends on like the future state of the universe. There might just be like apparent horizons. But yeah, those are like specific places in space. Are physicists more competent to talk about electricity than electrical engineers? It just depends on the question, I guess. Do you have a stance on whether change can occur atemporally? I would say that seems kind of nonsense to me. Is there any evidence of white holes? Not that I've seen, no. Let's skip down to the bottom. Do physicists in the US use imperial or metric? Well, look, we all use metric, but for communication purposes, sometimes imperial is helpful, especially if you're communicating to a US audience. What are apparent horizons? Apparent horizons are places, they're a type of quasi-local horizon that basically is, it's a radius, it's a distance away from a central singularity or some central mass, where at least, where we can think of even outward going light having to bend inward. That's one way of viewing it. There's a whole bunch of, in fact, I think I made a video about this a while ago, or if I didn't, I was thinking about it and I just never ended up doing it. But there's a whole bunch of different kinds of horizons and different kinds of surfaces that are relevant for like astrophysical black holes that are not ideal and don't actually have event horizons. You can have what are they called? You can have apparent horizons, dynamic horizons. You can have marginally outer trapped tubes. You can have and I'm missing like half a dozen more. There's basically like a lot of different kinds of ways of describing the boundary of a black hole when the black hole is non-trivial. It's when it's like evolving, when it's changing, when it's potentially merging, and stuff like that. If you hovered on the boundary line of the event horizon with your right side on one side and left side on the other, could the left side of your brain still communicate with the right? No. But you also can't hover there. But like for the split second where the right side of your brain is, for the split second where the right side of your brain is on one side and the left side of your brain is on the other, they couldn't communicate with each other, no. Sidim. As long as it's like genuinely the event horizon, right? Do you have any videos on the Fermi paradox? I think so, but probably from a very long time ago. Is entanglement a physical interaction, or do you take the view that it's a correlation with no space-time location? So entanglement does not communicate information between the two entangled particles. That's not a thing. I kind of take so my tendency, what I like to think about entanglement, this would be very conceptually nice, is if entanglement was just a breakdown of what distance itself means, that we only describe distance when there is that distance is only meaningful when we're talking about non-entangled systems. And so really we would say that, you know, distance is in some sense, distance or space is in some sense emergent from quantum correlations. That would be a really nice explanation, but that's kind of like vibes based. So if you can increase a black hole's volume without increasing the mass, you would decrease its volume. What? Well, at one point it's no longer a black hole. The question is what's left. You could increase a black hole's volume without increasing the mass. You would decrease its volume. What? You mean decrease its density? Well, no, the thing is you can't increase a black hole's volume without increasing its mass. By definition. A black hole's size is determined by its mass. Are we closer in size to the entire observable universe, or are we closer in size to the Planck length? We are closer in size to the entire observable universe. What's one thing in the science community viewed as true, but you're not convinced? Well, there's nothing that's like proper consensus, I don't think, that I'm not convinced of. Well, okay. Let's say that the existence of a cosmological constant I'm definitely not convinced of. And that is probably consensus, but it's probably a consensus that will be changing soon. You're kind of not nice, don't know why people watch you. If you were nicer, you would be more viral, Immo. I'm not nice. I don't know what internet you're on, but I'm like one of the nicest people on the internet. Now, that doesn't mean that I'm an angel. It's just, there are like, the vast majority of content creators are meaner than me. Like, that's crazy. You said you were working on figuring out what the state of the universe may have been at the time of the Big Bang by using the laws of physics now, and also what they could have been. Yeah, all I mean is that there is, depending on what describing the state of the universe 13.8 billion years ago or whatever, very much depends on what laws of physics you are using. Now, there are some like accepted laws of physics, but then there's more speculative stuff that is very similar to the accepted stuff, but is modified in a slightly different way, maybe to account for dark energy or maybe to account for whatever. All I'm saying is, if I want to use the standard laws of physics, just without adding anything speculative, to try to see what kinds of things can be allowed in the very early universe, that's what I was talking about. Are event horizons fully uniform like they're black holes? Well, event horizons kind of are the shape of the black hole. Event horizons, like, idealized black holes are, but for like dynamical black holes, they can wibble and wobble. Is the moon landing real? Yeah, of course. Yeah, MC Toon says you're too nice. Yeah, there you go. Coming from the OG Flurf Destroyer himself. From Mindforged Manacle, thank you for the $2. Blitz is quite nice. Yeah, I'm so nice. I'm so nice. I mean to like when people are like aggressive towards me or malicious towards me, then like, yeah, definitely, like I will return the favor. But like, you know. In 1972, there were no jerks on the internet aside from high-ranking military officials. True. Is the universe infinite, and how could we possibly know that? Well, it might be infinite. It would be really hard to know that, though. Yeah, how much do you bench, bro? 6,000 kilograms. How does the future of American science look? Oh, not good. In my view, very not good. So the comic does limit well change soon. Why are... I don't know what that's trying to say. I understand that there are typos there, so feel free to ask again and I'll try to answer it. What is the smallest unit of time? Ooh, as far as we know, there isn't one. There's no reason that we currently have to think that time is fundamentally pixelated. What planet do you bench 6,000 kilograms on? That's the right question. As a chemist who loves physics minus actually doing the math, what's your other favorite area of study outside of your physics mathematics? Those are the favorite ones. I don't really care for chemistry, to be honest. I don't really care for biology. But Blancs, it's actually funny that you mentioned this. There's a guy on here. There's a guy in here who I haven't thought about in a while, but he came up on my feed again yesterday. He's a chemist who thinks that, and you can just confirm for me, he thinks that chemists and biologists have to use all the same math as physicists do. That the mathematics that chemists and biologists have to do is just as hard, or the hardest math that chemists and biologists have to do is just as hard as the hardest math that physicists have to do. And I think that that's a little unlikely. I'm not saying that chemistry and physics is easier than, or sorry, chemistry and biology is easier than physics, because it's not. What I'm saying is that the difficulty of the mathematics in physics is probably harder than that, on average, is harder than that what's found in chemistry or biology. Chemistry and biology are harder in different ways, right? But this guy is like a crazy person who has a beef against physicists. I think probably because he couldn't handle. But who's to say he dropped out from his PhD program, his chemistry PhD program? So, a 6,000 kilogram object probably has its own significant gravitational field. Not really. Like a boulder will easily weigh 6,000 kilograms, right? Like a big sphere or rock, or like a cliff. But those don't really have significant gravitational fields. Do you have a PhD? I do. Depends on the chemistry. Physical chemistry has a ton of overlap. Well, yeah, but does physical chemistry have a lot of overlap with the mathematics that physics uses because has a lot of overlap with physics? Like, is it really the chemistry that has the lots of mathematics if it's physical chemistry that has the mathematics? I mean, I don't know. From Vader Sawyer with the $5. Thank you, Dr. Blitz. One more thought. Has anyone explored inertia as a topological defect of space itself, sort of an inertial topology idea? I haven't seen anybody doing that. Doesn't mean it's never happened. I just don't know the entire literature. So, run a search through Google Scholar. Actually, you know what? ChatGPT is very, very good for finding articles based off of kind of like vague ideas. Like, say, hey, you could just type that question to ChatGPT and it would tell you if anybody's thought about it. From Gretchen with the $6.66. I'll fight anyone who's mean to Blitz. Lamau, hashtag blame Blitz, JK. Yeah, I can fight my own battles. However, Sidim. Anyway, well, I appreciate that, Gretchen. And from Starglints with the $10, if past, present, and future are equal, has this moment always existed? How can we reconcile that the future is equal to the present without saying that every moment hasn't always existed? When you use words like always existed, you're implicitly giving a temporal notion to something that we're talking about in a non-temporal way. The point is that they're equally existent, not that it's always existed. Always is a time word. That's the trouble. How do you super chat? It's a YouTube thing. Many physicists have a heretic opinion according to current knowledge in physics. What's yours? I don't think the cosmological constant is real. Do PDEs modeling climate have the kind of nonlinearities that could result in solutions with jump discontinuities of temperature? I wouldn't be surprised. Like, nonlinearities are really, really messy, especially in climate modeling. That said, in like the real world, we should not expect jump discontinuities of temperature, right? That's probably non-physical. Because then it means that there is that you know, that there's like a real singularity, right? And singularity is not supposed to be real. I mean, you can have shocks, I guess, because temperature is like a coarse graining thing, so maybe you could have a jump discontinuity, but I don't know. I would be a little bit surprised if that could happen at the climate scale. And from Mr. Pacho, thank you so much, bud. Something Deeply Hidden talks about the wave function for the universe. Is this a thing that we know exists in the abstract, but almost certainly couldn't ever reasonably calculate or approximate? How do you think about it? Yeah, so first of all, we don't know that it exists at all. This is one particular interpretation of quantum mechanics, but granted that interpretation of quantum mechanics, we kind of treat it as this thing that exists in the abstract, and then we can kind of like approximate it. And so, like, for example, if you wanted to describe the wave function of a very, very boring universe, so this would be a universe that's uniformly filled with dust, non-interacting dust, and just evolves according to quantum mechanics, then you could describe that wave function in a pretty clean way. In fact, Stephen Hawking and James Hartle did something similar to this with their Hartle-Hawking state. But once you start adding complexities, the wave functions get really, really complex. And so, like, these are things that we have to kind of like approximate to try to understand different aspects of it. And, you know, it's kind of like a whole bunch of blind people trying to figure out what an elephant is. Except you know that there's an animal there. Where's my face? Right here. From Custom Site Sound, thank you for the $1. I appreciate that. Can we distinguish one photon from another? How about one electron from another? How do we know that we measure the same photon or electron we emit? Oh, no, we can't. Photons are indistinguishable from other photons. So if you have two photons with the same energy, they're indistinguishable from each other. Similarly, if you have two electrons that are otherwise in the same state, they're indistinguishable from each other. From Mitch Chiminski, thank you for the $5. What high school undergrad level physics concepts do you think is taught or shown in media poorly and incorrectly that causes widespread misunderstanding? Anything to do with quantum mechanics. Almost solely, like, if it's not a physicist talking about it, almost always anything to do with quantum mechanics is wrong. Did anyone try asking the photons their names? Photons don't have names. Why did you get into physics over other natural sciences? Well, because physics is math. At least it's the closest thing to math that you can get that still is a science. Also, it just, you know, black holes were cool. Strings were cool, right? Oh. Huh. From Dimbo with the $5. Blitz, you taught me electromagnetism physics a while back. Always remember how polarization is just clever use of refraction. Sending love. Well, hey, that's cool. I'm glad that you appreciate that. From Mind-Forged Manacle with the $5. When you say photons and electrons are indistinguishable from other photons and electrons, you don't just mean it's a knowledge limitation, right? No, they're actually indistinguishable. They're not just indistinguishable, they're identical, right? There is no meaningful difference between two electrons, except maybe like, you know, how fast they're moving or whatever it might be. There's just no difference. Every electron is identical to every other electron inherently. And then you can do stuff to them that makes them behave differently, of course. Is there a gravitational wave coming our way in August which was caused from a black hole? No. I'm going to make a video about this probably tomorrow. The answer is absolutely not. This is impossible to predict. We can't predict when gravitational waves will get to us. This is not something that we have the ability to do. Gravitational waves can't turn off gravity. This is all made up. This is literally just fiction. What is CERN actually trying to do? They're doing particle physics. They're trying to better understand the way fundamental particles behave. Wait, photons can move at different speeds? No, photons can't. Electrons can. Many Worlds Gang or Copenhagen Gang or what? Many Worlds Gang. I want to major in physics, however I dislike chemistry. Will there be a problem? Nope, I didn't take a single chemistry class in undergrad, and I majored in physics and mathematics. Supernova Einstein cross. Yeah, so what you're saying is that we could, yeah, so it is feasible that you could pick up gravitational waves. Well, no, because the light would be also bent in the same way. We wouldn't get the light signal before the gravitational wave signal. From Kelly Scher with the $5. I experienced a UFO many years ago, and I lack the education to express it. Any suggestions on how to smarten up? I'm old and have math dyscalculia. Well, look, I don't think that you need math in order to express your UFO experience. Just write it down. Write down your observations. What do you think about gravistars? I have a video on them. They're a neat idea. We don't have any evidence that they're real, but they're a neat idea, and that would explain what a black hole is. Isn't expanding space a completely religious concept? It doesn't emit light, you can't study it? No. I mean, like, you can study things indirectly. There are things that don't emit light that we can study, like neutrinos, for example. Neutrinos don't emit light. We can still study them, though. How do you account for probabilities in many worlds? So I've heard compelling cases that decision theory and self-locating uncertainty can be used to discuss probabilities in many worlds, but I've also seen critiques of this. So the derivation of the Born rule is one of the issues in many worlds, definitely. It's one of the outstanding issues. Blink twice if you were playing RuneScape on the side. I am not playing RuneScape on the side. I haven't played RuneScape in a while. I actually discontinued my membership last year, or at the end of 2024. What if dark energy is just us having the wrong equation to calculate energy? Well, it could be. So people work on that. People are considering alternative models of relativity. For example, there was this big hoopla about cotton gravity a few years back that I made some videos on. And cotton gravity is a proposed explanation to account for dark energy that doesn't actually have dark energy as like a required input. It just kind of falls out of it. But that has other issues. From Mike Gurney with the £2, is the cuckoo clock analogy for CERN correct? I'm not familiar with the cuckoo clock analogy. Let's type it in. Yeah, I don't know what you're referring to. Are you referring to like how we smash things open in order to see what's inside? Because then, yeah, that's a fine analogy. But I mean, it's not perfect, but it's fine. Will this one dude on TikTok eventually catch the atoms off guard and his hand will phase through? No, that won't happen. Man, this guy's really spamming the expanding space is just, let's highlight it. Expanding space is just like antique gods was, like Zeus. Zeus does not emit light. Well, yeah, I mean, Zeus doesn't emit light. Expanding space is detected indirectly, though. But like spamming it, you got your attention. Will you stop spamming now? No, we won't. Okay, I'll just mute him for the rest of the live stream. By the way, spamming doesn't get your thing highlighted. I just wanted to make fun of him because he's obviously a troll. Oh. Do you think that scientific development will ever reach a limit? I kind of doubt it. I love lamp too. I actually need to get a lava lamp. But I don't really have a place to put it where it'll be on display. So maybe I'll save up for a fancy lava lamp and get one of those when I inevitably get my own place with a studio. Like that's, that I can design from the ground up. Do you use the basic kinematic equations later on? For what? Physicist sounds certain you can't go into the past. Does this mean time can't loop forever? There's a lot of reasons why going into the past is probably impossible. But there's a few, like, loopholes. No pun intended. What sort of AI use is there in physics scholarly work? Obviously, it can't be much, but do you or others use it as a part of workflows to grab information? Yeah. So I've actually been using it as a. I like working collaboratively, and so if you guys had access to my papers, which you don't, you would find that most of my papers are not solo authors. Most of my papers are collaborations with other scientists, or mathematicians, just because I like having somebody to bounce ideas off of. So I've been using AI a lot for that. Like ChatGPT as like a way of, basically, it's kind of like talking to a rubber ducky, except the rubber ducky has access to the entire internet and can retrieve you sources for questions that you have. So I like to use it that way. I don't know how other people are using it, but I've used it as like a rubber ducky, and I've also used it as like a sophisticated search engine. So I think it has its place. From Mike Gurney with the £5, I have heard flirfs say CERN is like trying to work out how a cuckoo clock works by smashing two together and looking at the bits. Oh, yeah, and to an extent, yeah. But like, if you track the particles, if you track like the mechanisms, imagine that you smash two cuckoo clocks together, right? If you like very precisely track like where the springs go and the gears go in the subsequent explosion, and then you can like then you can actually like reassemble them and then figure out what was going on the inside. Like it's absolutely an apt analogy. It's just not a silly analogy. Like it's a real thing that you could do if you could track the particles. And at CERN, you can track the stuff this accurately. Math PhD student here. Can you explain what topological quantum field theories, the categorical notion introduced by Hilaire, Kontsevich, etc., have to do with quantum mechanics? No. I took a topological quantum field theory class in grad school, and the professor was lovely. He's a great guy. However, I did not understand like any of it. So no, I cannot. The best I can say is that topological quantum field theories just don't have any dynamics. They only have different topological states that are separated from each other. But that's all I know about it. I know like nothing about TQFTs. If gravitational waves carry energy away from a system, it means that they have energy themselves, so therefore have their own gravity. So gravity has gravity, infinite runaway gravity? Confused. Yes, gravity does have gravity. In fact, this is because gravity is described non-linearly by general relativity. It's not infinite. It's not infinite runaway gravity, because the gravity of a gravitational wave, like the gravitational, call it power, say, of a gravitational wave is much smaller than the gravitational wave itself is. And then the gravity from the gravitational power of the gravitational wave's power is smaller still. So like it is like an infinite sum, but it's convergent. That's the way to think about it. From Mindforged Manacle with the $5, CERN is using Kerr black holes to time travel and control the past, stay woke. True, but actually not true. From In the Life 475 with the $3 Australian, is it true clouds show gravity waves? Not gravitational waves. If by gravity waves you mean gravity waves in the same way that water has gravity waves, these are like the waves on the surface of water. I guess it could. I haven't heard this, but that seems plausible. Are any real solutions in sight for the three-body problem? The three-body problem was solved like 120 years ago by like a Finnish guy, if I remember correctly. The three-body problem, it's like we know what the solution is. It just doesn't have a closed-form finite solution. That's all. What's the difference between mathematical and theoretical physics? Mathematical physicists will write more math papers. Gas doesn't have gravity. Why not? What'd you get on your ACT? I think I got it's out of 36, right? Yeah, I think I got a 34. It was either a 34 or a 33. Are you a mathematical or theoretical physicist? I'm probably better classified as a mathematical physicist. So I have the hiccups and I need to be able to clear my throat and I can't. So like I'm kind of miserable right now. Oh. Is there a final answer to physics that the human race is hurling towards? I mean, yeah, in a sense. Like we're aiming to figure out all of this stuff, but who knows if we will ever finish it. Smashing a clock only to find it's made not of cogs and springs, but of other clocks, some as big as the original. Yes, that is the weird part about quantum mechanics. And well, actually, that's just the weird part about energy mass equivalence. From Custom Sighthound with the $5, do you agree per GR motion causes change of location in time? It is independent of cause and effect or entropy. Higher rate motion only appears to slow time. I don't think I understood well enough to agree. Motion doesn't cause change of location in time. Change of location in time is what we call motion. thank you for the question. Sorry I couldn't have a more sophisticated answer. Your opinion of the University of Arizona astronomy programs, I'm considering them. They're some of the best. U of A has an excellent astronomy program. So definitely, and like, definitely it's worth considering. I mean, like, if you can get into like Harvard, or if you get into like Yale or something, that's probably better. But U of A, as far as state schools go, I think it's one of the best for astronomy, actually. What do you think about time? Does it exist? Well, it exists insofar as it's like measurable, but like, is it fundamental? That's a different question. If a state of a particle can't be known until observed, was it in that state before observation? No, that's the, I mean, it could have been in that state, but it doesn't have to have been in that state before observation. That's one of the kind of consequences of standard quantum mechanics. Do you have a favorite physics law or maybe a favorite hypothesis? Yeah, I would say that my favorite is probably the Einstein field equations. That is in some sense a physics law. It's like Newton's universal law of gravitation, but souped up for general relativity. Is there any empirical evidence for a multiverse? Is it a hypothesis or a theory? Scientists and science communicators use the word theory differently from each other. Science communicators use the word theory to mean like some well-evidenced hypothesis or some well-evidenced model. Physicists just use the word theory to describe a mathematical model that has some interpretation. And so like, but just to be clear, like there's not really any smoking gun evidence of multiverse, if that's your question. From Drew Crew with the $5, energy is not conserved on a cosmic scale. Does that include information as well? Information and energy are not the same thing, so no, we don't have any reason to think that information is not conserved. Information being conserved is just a consequence of unitarity. And if you trust quantum mechanics, then unitarity is always true. Have you ever worked on data from the Arecibo telescope? Nope. Do horses exist? Yes, they do exist. Will there be any perfect black bodies in the universe? The closest things to a black body in the universe are black holes. What was before the Big Bang? We don't know. How do physicists feel about engineers? This is a question I get a lot, and I don't know why I get this question so often. Like, what does it even mean? Like, physicists are people. Different people have different feelings about different things, right? Like, I don't have any issue with engineers. Like, some engineers are, I'm sure some engineers are assholes. Some engineers are crazy people. Some engineers are normal people. So, like, why can't I put my hand through a table or other objects? Because there's stuff in the way. Could black holes just be wormholes with stars being the exit points? Probably not. Stable wormholes probably don't exist. There's something called the, if I remember correctly, it's called the mass inflation problem. Yeah, and so that basically destabilizes wormholes. From Mindforged Manacle with the $2. Who slighted the engineers? Who hurt you? Yeah, right? Like they're just a different kind of thing. Pretty sure Justin is an engineer? Yeah. Are you a mechanical materialist? I don't know what the word mechanical does there, but I wouldn't call myself a materialist, no. Are you familiar with the cognitive theoretic model of the universe? I'm familiar with it insofar as I've read about it. It is not anything to be taken seriously by anybody. Chris Langan is not a scientist. He doesn't know what he's talking about. Mic is not off. No, it's not. It's very much on. My mic is on. Wait. What do you mean? Was my mic off just a second ago? Okay. Is the universe infinite or infinitely expanding, and could the rate of expansion be much bigger? It can be both things. It can be expanding and it can be infinite at the same time. My dog stepped on the mute button. Okay, that's fair. That's funny. Is mass just another kind of energy? Is that what the Higgs boson shows? And sorry, keep asking. No, you're fine. Mass is sort of another kind of energy. But keep in mind, energy is not a substance, right? Mass is the energy of a thing when it is motionless, when it is at rest. What about this paper, Three-Dimensional Time, a Mathematical Framework for Fundamental Physics by Gunther Klatechka? That paper was published in a predatory journal, which makes me think that it wasn't a serious paper. How can it be infinite and expanding? Because expansion is a local thing. Expansion is a thing that happens within the universe. It doesn't happen at the edges, because there are no edges. Did Bell's theorem rule out local hidden variable interpretations? Yes. Well, at least the experiments did. If the universe was spinning, how could we know? What would it be spinning in relation to? It's a good question. So it could have angular momentum that is pointing in a direction. And it wouldn't be relative to, like, angular momentum is not relative, by the way. Angular momentum is not, it is in some sense absolute, at least locally. But which would just mean that the universe would have a net zero, or a non-zero net angular momentum. That's all. That's what it would mean for the universe to be spinning, basically. Oh, my stomach is a rumbling. Could the universe have a global charge? I suppose it could, but it very much probably doesn't. Do you have information about element 115 and how it was created in a collider? What would happen if we could create a stable version of 115? You can't create a stable version of 115. It's not a stable element. It was created in, what year was it? It's Moscovium, if I remember correctly. It was created in 2016. Well, that's when it was named. I guess it was made in 2015. No, I'm sorry. It was first made in 2003, but it was recognized as a new element in 2015. The point is that there's nothing that you can do to make it stable. Like, there's no law of physics that would let you do that. With E equals mc squared, what theoretical ideas could let us travel faster than light without breaking relativity? You can't travel faster than light without breaking relativity, without having negative mass. If you have negative mass, then you can do like a warp drive thing. No possibilities of stable isotopes? No. At least not more stable than the nearby elements, not more stable than, say, element 114. And the reason I say that is because element 115 has an odd number of protons, and an odd number of protons will always be less stable than an even number of protons. A similar number of even number of protons. So 115 will always be less stable than 114. There's nothing that you can do to make it more stable than that. What's your opinion on the Atlas comet? Is it alien tech? No, it's a comet. It's been a comet this whole time. We've known it's a comet this whole time. There's only one guy who thought it wasn't a comet, and for some reason he got all of the media attention. Oh. You like Arch Enemy? Not really. Do you think there are likely non-local hidden variables? Well, okay, kind of. Insofar as, like, I'm like a many worlds guy, in which case there's not really hidden variables insofar as there's like a wave function, and that wave function encapsulates everything, but you know, not in the traditional sense, I guess. Could there be a way to explain, like, I'm 15 as it decays in an... I don't know what that... Oh, could there be a way to create element 115 as it decays in an energy efficient way? No. Because you never get more energy out than you get in. And it takes a bunch of energy to make. So, no. When virtual particles are created, so scientists have an idea where the energy is being borrowed from, though they're short. Virtual particles are not created. Virtual particles don't exist. They're made up. Hooey. Hoopla. Nonsense. Nothing. They don't exist. Not real. Is Avi Loeb serious? When he does cosmology, when he does actual astrophysics, he's absolutely a serious scientist. But then sometimes he just talks about aliens, and then he's just like a crank. All right, y'all. I've been live for just over an hour and a half. I should end the live here because my stomach is rumbling. So I'm going to do that. But before I go, I want to remind you that you guys, if you're 18 plus, make sure to join the Discord server. It's a great way to get announcements from me when I'm live, when I'm doing the Ask a Physicist, when I'm doing debates, when I post a YouTube video, when I post a TikTok video. Whenever I do anything, you'll get an announcement in my Discord server. You can also ask me questions and talk with like-minded people there. You can also interact cross-platform that way. There's people watching on TikTok, there's people watching on YouTube. Everybody can talk in the live stream chat on the Discord server. Second thing, if you guys want access to my debate notes, if you want access to the emojis, consider becoming a YouTube member. It's like $4 or $5 a month. And then, you know, you can join the Illuminati because we like lava lamps here. The Discord is Discord. If you want to go to the Discord server, it's really easy to get to. You don't even need to remember anything. Discord.gg/Dr. Blitz, Dr. Blitz. Just type that in, you'll get to the Discord server. We have our own fancy invite link and everything. There is a link though in the link tree in my bio and in the description of the YouTube video. So I'll see you guys there, and I'll see you tomorrow for some more Ask a Physicist. Take care, everybody. Oh, hold on. Before I go, gotta make sure I didn't miss any cash apps or things. Okay. I didn't miss any, so we're good. All right, now goodbye.